Oh my goodness. Is that Lunkle? Oh yeah, it's me, Lunkle, here in charge of programming short number 1. Let's get into business. 5 weeks ago, we implemented chunk loading. But chunk loading is only half the story, so today we're going to be implementing the other half, chunk saving. To save chunks, we need to follow the same convention that we used to load them. In devlog 3, we outline the basic structure of a saved chunk file. We store each chunk in a file with name given by the coordinates of that chunk. In the file, we have a 16 by 16 grid of tile types, specifying the type of each tile. And lastly, for each entity inside the chunk, we list out the entity's type, image, and position relative to the top left of the chunk. And you might ask, Lunkle, which chunks do we save? All of them? Good question. These two categories of chunks require saving. Number 1, newly generated chunks, and number 2, changed chunks. Without further ado, let's jump into the code. Alright, so let's quickly make a chunk saver class which we will be using to save chunks. For the constructor, we're going to need a list of chunks we need to save, the name of the world stored in this game world info class, and an image to string map that tells us a given image's load path. Let's save these parameters as class variables, and now let's move on to the actual save function. The save function should also take in a frame data, thanks to the buffered rendering we implemented in devlog 5. So first, we'll just make a for loop, looping for each chunk in our chunk list. To write to a file, we're going to be using the built-in class called buffered writer. The syntax to use buffered writer is like so. And we'll just make this function throw an IO exception to avoid try catches. Next, for each tile in the 16 by 16 tile grid, we're going to have to turn that tile into a tile index. From devlog 3 in our tile factory, we already have an ID to tile type hashmap for chunk reading. Similarly, we're going to need a tile type to ID hashmap, like the opposite. And back to our save chunks function. We'll get this map that we just made once at the beginning and write out each tile type to the file. Done. But we're only halfway. We also want to save entity data. We arbitrarily decided in devlog 3 that we would be saving each entity in the following format. Type, for example, like obstacle, mob, decoration, name of the image, and the coordinates relative to the number of tiles from the top left of the chunk. Again, from devlog 3, we have a char to entity type hashmap for entity reading, so we'll quickly create a reverse map for entity saving. Moving on to coordinates. In the game, we store the position of each entity by its pixel coordinates relative to the world origin. However, we want to store it in terms of tiles from the top left of the chunk. To convert, we, number 1, find the vector from world origin to the top left of the chunk. Get the pixel coordinates of the entity. Subtract the chunk coordinates from the pixel coordinates of the entity. Now convert the resulting coordinates to tile coordinates. Done! Easy! Now we actually need to use our chunk saver class somewhere. So for now, let's keep things simple and use it when we exit our game. So let's go to our Nomads game logic and add to our exit lambda. Create our chunk saver with a list of chunks, null for now, our selected game world, and the reverse image map. Now let's call save chunks with the current frame data. Okay, so which chunks do we actually save? Let's go into our game world object in Nomads game data, where all the chunks are actually loaded and stored during game time. Alright, let's make a list of 2 save chunks, which should store newly generated chunks and or edited chunks. Currently, the player can't actually edit the world, so let's only focus on newly generated chunks. So if a chunk is made through a chunk generator, add it to the list. Done. Make some getters for the list, and then go back to our exit code and call the getters. Let's run and see what happens. Jiggle around to load some chunks other than the 2 we manually made, and bam! File saved. This is legit. So, today we implemented chunk saving into Nomads. Chunk saving will prevent us from having to regenerate every chunk each play session, and as well in the future when we allow players to interact with the world, we can store those changes so they become permanent. Okay, my friends, if you see possible optimizations, don't be gentle, point them out. You'll be rewarded with a comment about how great you are. Cheers!